All right, let's look at composition of linear transformations. Um, we can take the composition of two functions f and g. Uh, this notation here, f of g, means you plug g into f, and g of f means you plug f into g. And we can do the same thing with linear transformations. The only thing is we have to make sure that the sizes of vectors all match up, or in other words, the codomains and the domains match up correctly. So suppose we have this. We've got T maps Rm to Rn, and S maps Rn to Rk. So if you think about what this does, we've got three things. We've got Rm, we've got Rn, and we've got Rk. And let's see. T takes M to N, and then S takes Rn to Rk. So what we could do is we could do S of T of X, because basically the input of S, well, if you think about it, this is S of T of X. So the output of T becomes the input of S, but it doesn't work the other way around. Let's write this out a little bit. Suppose we've got this. I'm going to write this kind of small. If T maps Rm to Rn, that means you've got this matrix times something from Rm. Whoops. So this is m by 1. And it gives us something that's n by 1. So this matrix over here has to be n by m. And similarly over here, we've got a matrix. It's going to take an input of something that's n by 1. It's going to give an output that's m by 1. So this over here has to be, or no, the output is k by 1. So this has to be an n by k matrix. Or no, that's backward. It has to be a k by n matrix. That way these match up, and this gives us the size over here. So this is k by n. So which way can we multiply these? Can we multiply AB or can we multiply BA? Well, let's see. It looks like we can multiply B times A. And that's going to be the standard matrix for, let's see, since A is the first one applied, that's T. So you get S of T there. So all of that stuff is summarized here in this box. If T1 is a transformation that goes from Rn to Rm, and T2 goes from Rm to Rp, and their standard matrices are A1 and A2 respectively, then you can define T as this composition, and the matrix there is going to be A2, A1. All right, so let's do an example. Let T1 and T2 map R3 to R3, defined by this. Now this one, we've got both of these have R3 as their domain and codomain. So in a case like this, we can define T of T2 of T1 and T1 of T2. So let's work out the matrices. So for T2, let's see, we've got the matrix A2, which is just going to be the coefficients of this. So for that first one, we've got 2x, so that's going to be 2, 0, 0. Then 2y will be 0, 2, 0. And this will be 0, 0, 2. Okay, to get T1, or for T1, to get its matrix, maybe it's worth writing this stuff in. This is a matrix. We multiply it by x, y, z, and what do we get out of this? We get z, x plus y, and x. So if we look at what we have to multiply this by in order to get this, for the top line, we've got 0x, 0y, 1z. For this line, we've got 1x, 1y, no z. And for the last line, we've got 1x, no y, no z. Okay, so those are our two matrices. So the standard matrix for T2 after T1, we've got to multiply these together. So this has matrix A. And notice up here, if you're doing, the order stays the same throughout. So T2 of T1, that's A2 times A1. So this is going to be A2 times A1 equals something. Now, this is actually something we can do pretty quickly. If you multiply A2 times this A1, let's see, we get this times that. Notice all it's going to do is double the top number and the rest zeros. So this is going to be 0, 0, 2. Then when we multiply this times each of these, it's going to double the middle number. So we're going to get 2, 2, 0. The last one is going to double the last number, so we get 2, 0, 0. So here we'll multiply these two matrices together. And again, this is a pretty easy multiplication to do. If we take this row and dot it with each column, we're going to get 0, 0, 2. You know, another way of thinking of that is it's just going to give us the last, the bottom row, added the bottom row. This is going to give us the top plus the middle. So we take that and do it across here, we're going to get 2, 2, 0. And then the last one is just going to give us the top entry. So we'll get 2, 0, 0. All right, so those are the standard matrices for these two composite maps. Okay, this next one, find the standard matrix for the inverse of T2 after T1 from the previous example. So that's the inverse of this. Well, the inverse of that matrix is going to be something. We could work it out. I'm sure it wouldn't take but a minute, but we're going to use octave. Let's see, that's 0, 0, 2, 2, 2, 0, 2, 0, 0. And its inverse, let's see, we've got 0, 0, half, 0, half, minus a half, half, 0, 0. All right.